Good day, ladies and gentlemen. This is Banners Online Maths. We have one of the problems and limits on the board. Look at this. We're asked to solve limit as x approaches 0 of this function, which is e to power x minus e to power minus x all upon 4 sine x. Solution. Given that limit as x approaches 0 of the function e to power x minus e to power minus x all upon 4 sine x. Since x approaches 0, you don't waste time, you take the limit. Taking the limit, since x approaches 0, which simply means here in this function, wherever you see x, you replace it to be 0. So, of course, that simply becomes e to power x. Instead of x, we have 0 minus, we now have here to be e to power minus, instead of x, we have 0. All upon 4 sine, instead of x, we have 0. Therefore, this is the same thing as e to power 0 minus, of course, minus times 0 would be equals to 0. All upon 4 sine 0 will automatically give us 0. As a matter of fact, we now have this to be equals to e to power 0 from the law of indices. Anything that raises itself to power 0 automatically becomes 1. Have that in your mind. So therefore, e to power 0 will automatically be 1 from the law of indices. This minus is this. Coming up here, e to power 0 automatically is equal to 1. All upon 4 times 0 will give us 0. Such that we now have that 1 minus 1 automatically is said to be 0, all upon what? 0. So 0 divided by 0 does not exist. It's said to be indeterminate because sometimes if you use your calculator to punch, you find out that the calculator will say error or mass error or sign error. Provided there is error there, which means that such function does not exist and was not programmed inside the calculator. So as a matter of fact, we should know that 0 divided by 0 is said to be indeterminate. Of course, the function that resulted to this is this given function, which is limits as x approaches 0 of e to power x minus e to power minus x all upon 4 sine x. Now, once the limit of the function is indeterminate, there are 3 things to consider for us to have a solution. One, either you apply factorization method, or you apply rationalization method, or you apply L'Hopital's rule. So in this function, of course, you can factorize to solve the problem. You can also not apply rationalization method, but L'Hopital's rule will hold. So we are going to apply L'Hopital's rule here. And what does L'Hopital's rule state? L'Hopital's rule states that you differentiate the numerator separately and the denominator, and the derivative have to be term by term. Applying L'Hopital's rule, That is differentiating both the numerator and the denominator separately. Hence, term by term. So if we apply L'Hopital's rule, which simply means that we are going to differentiate both the numerator and the denominator separately. So that will give us limits as x approaches 0 of, now look at the first term. The first term is this an exponential function, e to power x. From the standard derivative, once you differentiate e to power x, automatically we'll have the same thing. So this is going to be e to power x. Then we have minus. Now coming up here, we want to differentiate e to power minus x. From the standard derivative, if we are given e to power ax, if we are given e to power as, and you ask to differentiate this, so automatically this will be e to power ax from the standard derivative. So this can be gotten using function of a function. If I apply function of a function, you will get exactly this. But for now, you should know that this, when you differentiate this kind of thing, you will have this. Example, if you differentiate e to power 2x, we are going to have 2 e to power 2x. Therefore, if we differentiate e to power minus x, of course, the coefficient here is minus 1. So this is going to be minus e to power minus x. So please take note of this. Hence, if we now differentiate this, we are going to have that, giving us minus e to power minus x. All upon, now coming here, 4 is a constant. So bring it out, that's 4. Hence, the derivative has to be on x. Differentiate sine x, we are going to have cos x.